When you listen to a lecture in class, the language used is probably very formal. Grammar rules are observed, and syntax and vocabulary can get quite complex based on the topic. Some other examples of the use of formal language can be found in courts and other legal institutions. Now let's consider the way people talk in their everyday life. There's lots of slang. Grammar rules are bent and broken, and the entire delivery is colloquial. There are many styles in every human language, and they all perform the exact same function: communication. The same can also be said about computer languages. They too have various styles, also known as programming paradigms. And just like in human languages, no one style is better suited than the other. In programming, there are two commonly used paradigms: functional programming, sometimes abbreviated as FP, and object-oriented programming, sometimes abbreviated as OOP. You can think of these paradigms as different approaches to writing code. But the result is still the same: instructing a computer to perform a set of operations. In this lesson, you will learn about functional programming. So let's now focus on the functional programming style. There is a clear distinction between data and functions in functional programming, as data can exist outside of functions. For example, you may recall that when functions need some data, you pass them the values in the form of arguments. Then a function performs some work on the given data and returns some values that you can then use somewhere else in your program. An alternative paradigm is the object-oriented programming paradigm, where you combine both data and functions into objects. You'll learn more about object-oriented programming later. Now let's examine a practical implementation of the functional programming style using a coding example to calculate currency conversion. Okay, so in this example of functional programming, let me start by giving my program some data. The purpose of the program is to perform currency conversions. Notice that I already have a variable declared with the name currency1 and assigned it the value of 100. Next, I'll add two more variables: currency2, which is assigned a value of 0, and exchange rate, which is set to 1.2. Notice that I have declared all these variable names using camel case. This is where the first letter of the first word is lowercase, and the first letter of the subsequent words are without spaces and in uppercase. Next, I can create the function that will work with these variables and operate on this data. First, I create a function named convertCurrency that accepts two parameters, amount and rate. Then, in the function's body, I return the result of the amount multiplied by the rate. Basically, I'm coding it to multiply the two values it receives and return the result. Next, I need to update the value of currency2, which was previously defined on line 4, assigned to the value of 0. To do this, I call the convertCurrency function with arguments of currency1 and exchange rate, and I assign the value returned from this function call to the currency2 variable. Recall that when the function is invoked, it will return a value, which will be assigned to the variable currency2. It's important to remember that I need to also pass the two arguments required for my function to work. In this example, I'm sending the variables currency1 and exchange rate. Basically, I'm passing the values 100 and 1.2 to the function so it can perform its calculation and return the result. Finally, I console log the value of currency2 to test my code. Success! 120 is output to the console, the result of 100 multiplied by 1.2. In this lesson, you learned about functional programming and how it can be used to solve a problem by separating data from functions. Great job!